Welcome to another exciting edition of Comet Algebra. This video is to review factoring before you begin Chapter 9, just in case you may have forgotten some of this. We're going to review the three types of factoring that you learned in Algebra 1. First one is GCF, where you take out the greatest common factor of each term. The second is when you have a trinomial that can be factored into two binomials. Sometimes we call this the diamond method. If there's a coefficient in front of the x squared other than 1, then it could be a diamond box problem. And the third one is special cases where you have like the difference of two perfect squares. So let's look at the first example. This one is a GCF example because just scanning across it, they all share a common factor. So for the 12, the 28, and the 8, I believe they all share a 4. So we'll write that number part of our GCF, and then we'll check our letters. X cubed, x squared, and x, so they all share an x. And then y squared, and y cubed, they all share a y. So then we simply divide it out of each term. So dividing each term by the 4xy, 12 divided by 4 is 3, x cubed y divided by xy is just leaves us an x squared, and so on. 28 divided by 4 is 7, xy, and when we divide out the last term by 4xy, we're left with 2y squared. Now sometimes when you use GCF, you're done at this stage. You've taken out the GCF, there's nothing left to do, but you always need to check. Look at what is left inside parentheses here and see if you can factor another step using another method. And in this case, indeed, we can. So I'm going to review the diamond box in an example coming up here. So I'm going to do this one by guessing and checking because I know students use both these methods and I know you prefer one over the other, so I'll try to review both. So to get a 3x squared, we know we're going to have a 3x and an x. To get a 2y squared, we know we're going to have a 2y and a y, but we're not sure where to put them. So I start planning ahead. I'm looking at this middle term, knowing that I have to get a 7xy with my outer and inner product added together. So you can just start trying. You can try putting the 2y in the first one, but planning ahead that I'm going to get a 2xy and a 3xy, which only adds up to 5. So I'm going to try putting the 2y back here because planning ahead, I'm seeing a 3x times 2y giving me a 6xy. So this is, to me, getting me closer to that 7. So I'm just going to, using the guess and check method, I'm going to try the y here and the 2y there. And now I'm going to check the outer and inner product. In other words, I'm going to FOIL these two binomials and make sure I end up with this trinomial I started with. So first times first is 3x squared, we're fine. This outer product here is 6xy, and this inner product right here is xy, or we think of it, of course, as 1xy. And that indeed does add up to 7xy. And then the last times the last, of course, is 2y squared. So now this first example is completely factored. We did the GCF first, and then we used the guess and check method. All right, the second example, we have a trinomial, and it can be factored, hopefully, into two binomials. So let's do this one with the diamond method. So to review that, we make our diamond over here. On the top of the diamond goes the first term times the last term. So we have a negative 42y squared. The bottom of the diamond goes the middle term, which is a y, and we think of it as a 1y. So we need to come up with the two factors that when I multiply them, I get negative 42y squared, and when I add them, I get 1y. So the factors have to be very close together. 1 and 42, 2 and 21. It looks like it's going to be 6 and 7. So we have a 6y and a 7y. 6 times 7 is 42, and they're 1 unit apart. So you ask yourself, where's the positive and negative go in order to make this a positive 1? And the 6 would have to be negative. Since the leading coefficient on my y squared is a 1, this is just a diamond problem. So we just use the factors that we found. And that is completely factored. Now for number 3. Not a trinomial. They do not have a GCF. So we're kind of stuck. We need to think about those special cases. And hopefully we notice that both of these are perfect squares. And so in Algebra 1, I used to call this a conjugate problem, where there is no middle term for the trinomial. So they must have subtracted to 0. So for two perfect squares, we have to recall that it's the square root plus each other and the square roots minus each other, which by definition these two are conjugates. And then always checking, if you FOIL this quickly, 2x times 2x is 4x squared. The inner product is 10x. The outer product is a negative 10x, and they do add to 0. And then the last times last gives me the negative 25. So that is completely factored. All right, in example number 4, it is a trinomial. It is going to be factored into two binomials, but your life will be so much easier if you always remember to look for the GCF first. So in this case, scanning across the problem, they all share a 3, and they all share an x. So let's factor that out first as a GCF. We are left with x squared minus 4x minus, 21. Okay, so once again, we've completed the first step in factoring, and we need to look what is left inside the parentheses to see if we can factor further. And we can. This is a diamond problem. Perhaps some of you can do this one with mental math. What two numbers do I multiply to get negative 21, and yet I add them to get negative 4? So you're really asking your brain to do two operations at once, which our brains don't really like. But 7 times 3 is 21, and they're 4 units apart. And if I make the 7 negative, then when I FOIL this, again checking the outer and inner product, a negative 7x plus a 3x gives me that negative 4x. So now it's completely factored. All right, in example 5, we notice that we have a coefficient in front of the x squared, and there is no GCF to simplify this. So I will use the diamond box method here. Some of you will guess and check, and that is fine. I just wanted to be able to show you both methods. So when we do the diamond box, first times last goes in the top part. So we have a negative 10x squared and a 3x down below. So we ask ourselves, what two factors can we multiply to get the negative 10 and yet add and come up with a positive 3? So if I have 5x and a negative 2x, that would give me both the negative 10 and the positive 3. So now we move over to the box part in order to undo these factors. Okay, so just to remind you what goes inside the box, diagonally from one another, we need to have the first and the last term of the trinomial. So as long as they're diagonal from one another, you can put them anywhere you want in the box. And then these two factors that we found need to go into the box, again, diagonal from one another. It would not matter which one you put where. Now we undo the box to get 2x squared. I'm going to need the 2x on this side, so I put it, I'm planning ahead here, the x here. Then I need the 5 and 2x times 1 is 2x. So now we got to figure out where we need our negative sign. This is positive, this negative 5 over here, so I'm going to need the 1 to be negative. So now, after the box, we have done the work needed to undo these factors, and the factored form is x minus 1 and 2x plus 5. All right, this last example is just reminding you that there may not be numbers involved, but we still factor it as usual. Not a trinomial, not a diamond box, no GCF. So hopefully you recognize these are both perfect squares, and it factors into x plus y and x minus y. So again, difference of two perfect squares, we could call that a conjugate problem because the middle terms, the outer and the inner product, subtract away. All right, hope this helps with your factoring.